Hey guys, welcome back to the next video. In this video, we are going to talk about two concepts over here. One is container, another one is container orchestration. Now here for container, we have multiple tools like Docker and Cairo, and for container orchestration, we're going to use Kubernetes. But then, just for example, we'll be using not any hands-on, just understanding architecture. Now, please remember one thing, we've already spoken about containers already, but in this video, we are also going to see about containers in a different architecture. Now, what I'm going to do is first I'm going to tell you about the container, explain you the architecture, and then I'm going to pinpoint those things which is missing in terms of a container. Then I'm going to add those missing features in the container orchestration so that you will have a clear understanding of what is actually missing and how container orchestration or orchestrator would be able to fulfill those requirements. All right, welcome to this presentation. So now you can see that this is users trying to connect to this Nginx and then goes to the app 1, app 2 of which is our library application, so which is hosted with Open Liberty or Liberty for that matter. I'm not worried about what it is using here. So that is again connected one side to Prometheus for data analysis and Grafana for graphical analysis. And then you have the MongoDB over here, which is connected to MongoDB for the matter of understanding the database related components. Just a correction, Prometheus you use for monitoring and tracking all those problematic containers and cloud operating system. So if I've said anything else, please ignore it. So that's basically is the architecture which is I want to project to you in terms of a containerized architecture. Now, we are here using Docker in this specific scenario at this point in time. Now, if you see that how many containers we have about 6 containers. Now, what these containers are directly downloaded from Docker. So these are basically the smaller versions or the miniature versions of your operating systems, which is designed to perform only those specific tasks. Like, for example, you can download a container from Docker image, which basically is just about installing your Nginx on it, but it comes pre-installed. You don't really have to install anything. So if you just download the image from Docker Hub for Nginx, it's going to come with an operating system and the native support for your Nginx. So those are the only 2 things which is going to be covered. You can inflate it. There's no reason why you shouldn't. If you have the requirement, for example, you want to have some extra modules there, you can go ahead. You will have SSH. You can connect to those instances of Docker container, and you can connect and you can inflate it by installing more modules into that. For example, you want to use mod rewrite, or you want to use some kind of a proxy module which is not there, mod cluster you want to use, go ahead and install it. There's no reason that you should not. It all works fine. So in terms of my library application, I have the app 1 over here, app 2 over here. Our EAF file is deployed. Let's take for example, we have Docker image for Open Liberty. So we can use Open Liberty as our application server and deploy it on top of these 2 Docker images and then transmit the load between the Nginx to Open Liberty. That's also something which is possible. And then one side of this is connected to Prometheus for monitoring and Grafana over here. So you can see that the connection between Prometheus and Grafana. On the other hand, you can see it is using the MongoDB over here for the database related activities. So a total of 6 containers are present over here. This is basically what containers we spoke earlier about. Previously, we didn't name any of the containers or the usage of the containers. In this video, you have the proper utilization of the containers and how we can use Docker to create these containers. So this is the similar architecture what you will find in terms of working with a virtualization environment or physical server environment. The same thing is what you're going to get to over here as well. But then these Docker images are very small in size, which means that you can scale up and scale down pretty immediately. And you're going to run application like Nginx, and you're going to run applications like Liberty, which is much faster in terms of working with it. And also remember, your application is now it's a micro service space, so which means you're going to divide. You're not going to put in very much bigger logic inside that. You're going to divide the logic, and you're going to make it multiple separate logics. So that's why it makes it faster. That's why it makes it versatile. So now let's talk about what is missing over here. For example, if you want to have another Liberty server for application 3, or you want to have a load balancing facility for your app 1 and app 2, one more instances of it, I have to do it manually. So I have to run some commands and invoke Docker to create more instances to scale up. Or if I want to remove those servers, right? You remove those services. I want to remove those services, then I have to do it manually. So this kind of get me a lot of manual activity over here for scaling up and scaling down. Remember also that if some of the server instances crashes, or the nodes here which is running crashes, then I have to manually start them up, figure out the problem, and then bring them up, and then I need to create another spare instances for whatever has gone down, and since I need to do that. And then the complexity of running new stuff in production increases because again, manual intervention is required over here. Scaling becomes more burden for us, for me, and it becomes very difficult. In terms of these activities which I spoke about, you need more people to do that. So you need to hire more than one person to take care of your environment. If something goes wrong, someone has to be there always. And when you talk about public cloud providers, your bill becomes more expensive if someone forgets to scale down the servers whenever it's not being used, right? So these are the real-time scenarios when you don't have an orchestrator. This is very simple and straightforward. So orchestration or orchestrator is going to take care of all these instances. They're going to build replications for these instances. They're going to be there when the instances goes down. They're going to bring it back up. So let's just say, for example, that this is the architecture, the same derived from the same item up there. So now here, sorry about the small size. There's no way I can fit all these three into this. So I have created the same format over here and pasted it over here 3 times. Why? Because we have the Kubernetes orchestrator on top of it. So user connects to any of the web servers where the Kubernetes will manage. And then it can also add an additional set of these servers one more time over here if it requires, where it sees that the user load is becoming higher. So it will logically add another group of servers over here, and it basically starts sending, allowing it to serve the user request. This is the advantage of using Orchestrator over here. In this example, we are planning to use Kubernetes in this case. So you have the containers over here. Now these containers will be populated automatically, and it would be taken care of with Kubernetes service. This is just an example to show you. Do not worry about this Prometheus and Grafana at this moment. So that may be outside the Kubernetes. All right. So that's it I want to tell you guys, because I just want to show you what's the difference between a containerization and orchestration. So if you are going for containerization, it is very well advised that you should have some kind of orchestrator who can perform orchestrating or planning your environment and taking care of your environment. Thanks for watching this video. I'll see you on the next one.